stress amplitude versus log cycles to failure problem. The fatigue data for a brass alloy are given as follows. For a stress amplitude of 170 megapascals, the cycles to failure are 3.7 times 10 to the fourth. For 148, it is 1 times 10 to the fifth. For 130, it is 3 times 10 to the fifth. For 114, it is 1 times 10 to the sixth. For 92, it is 1 times 10 to the seventh. For 80, it is 1 times 10 to the eighth. And for 74, it is 1 times 10 to the ninth. Our first objective is to make a stress amplitude versus logarithm cycles to failure plot, otherwise known as an SN plot. In order to do this, we need to find the logarithm cycles to failure. This can be done using log properties, so the log of x equals alpha, as well as 10 to the alpha equals x. Right now we have cycles to failure, otherwise known as x, and we need to find the log cycles to failure, which would represent alpha in this case. So we go ahead and add a column to this. And plugging this into the formula for 3.7 times 10 to the fourth, we get 4.57 log cycles to failure. For 1 times 10 to the fifth, we get 5. 3 times 10 to the fifth, we get 5.48. 1 times 10 to the sixth, we get 6. 1 times 10 to the seventh, we get 7. 1 times 10 to the eighth, we get 8. And 1 times 10 to the ninth, we get 9. Now we go ahead and plot these. So on the x-axis, we're going to have the log cycles to failure. This is otherwise known as n. And on the y-axis, we're going to have the stress amplitude. And this is going to be in megapascals. And this is otherwise known as S. So we have our S versus N. We're going to go ahead and plot the data now. So the cycles to failure goes from 4.57 to 9. So we can start our axis at 4 and do increments of 1. So 5, 6, 7, 8, and 9. And our stress amplitude goes from 74 to 170, so we can start at 60 and go in increments of 20, 100, 120, 140, 160, and 180. Now we go ahead and plot our data. So for the stress amplitude of 170 up here, we have a log cycles to failure of 4.57, which is going to be right about here. At 5 log cycles to failure, we have 148, which will be right about here. At 5.48 log cycles to failure, we have 130 stress amplitude, which will be right over here. At 6, we have 114. At 7, we have 92. At 8, we have 80. And at 9, we have 74, which we can now go ahead and connect this to find our trend. And we have an S versus N plot. Next up, we need to find the fatigue strength at 5 times 10 to the 6 cycles. So in order to this, we need to convert to log cycles once again. So the log of 5 times 10 to the 6 is going to go ahead and equal 6.7. So we'll locate this spot on our graph, 6.7, which will be right about here. We'll move up there. This is now our spot, and we'll move across the axis to 100. So our fatigue stress strength at 6.7 log cycles to failure is going to be 100 megapascals. Next up, we need to find the fatigue life for 160 megapascals. So this time we'll go to the y-axis over here and move over. From there we find our spot, and now we'll move down. And this is going to go ahead and be about 4.6. So that's log cycles to failure, but we need to find cycles to failure. So we'll go ahead and use this property. So 10 to 4.6. If you type that into the calculator, you go ahead and find a value of 3.98 times 10 to the fourth. So that means it is 3.98 times 10 to the fourth cycles.